I've had the idea of 3D printing an O-scale rail car kicking around in the back of my head for a while now. So, on a rainy Saturday afternoon, I decided to start modeling parts for one. I started with the wheels and axles. I used the profile of a Lionel wheel as an example. The axle is square to make it adhere to the print bed better. The ends are slightly rounded to hopefully make them turn smoother in the truck. I test printed a pair of wheels and an axle. To my surprise, the wheels press fit quite nicely onto the axle with only minimal cleanup on the ends where the support was touching it. Next was the truck. This design is also based on its Lionel counterpart. It prints with supports that peel off nicely, and the wheel sets snap into position. They spin quite a bit more freely than I expected. I decided to start with a design for a flat car because it should be the easiest type of rail car to design and print. I whipped up a simple model and printed it out. The trucks are attached onto the car body with small pins. These were meant to be press fit, but I found some glue was required. The assembled car rolled nicely while pushing it back and forth on a short piece of test track, so I started designing a boxcar. This process consisted of fighting with pattern tools for a few hours. I could have added more details, but I got tired of dealing with Fusion 360. Printing this design was a challenge, not because the model is particularly complex, but because I made the mistake of using tree supports the first time I tried to print it. The supports ended up getting knocked off the build plate midway through the print. Instead of restarting the print from scratch, I cut the model in Fusion 360 and printed the other half. Unfortunately, this time the printer stopped with a min temp error. Turns out this is because the hot end thermistor wiring got damaged from the failed support material on the last print. So after some printer repairs, I cut the model again and printed pretty much just the roof of the car. All three of these pieces were glued together. Then I printed out the doors and the top tracks for the doors as separate pieces. To attach the door assemblies, the door is placed into position and the top track press fits into a few slots on the top of the car. In the end, this boxcar wound up being 3 pieces glued together. Looks okay, at least from a distance. Has less detailing than the Lionel counterpart, and is obviously missing all forms of letterings and markings. I also noticed the door tracks ended up being a little bit too long, which allows the door to slide further open than it should. Also, the doors themselves should be a touch wider to block any gaps around the holes in the car body. Otherwise, the doors open and close well, but they are a little loose, so they can shift around on their own a little bit, which is much like the real Lionel car. But the real question is, will these cars roll on a model train layout? Up until this point, I have not attempted to pull either car behind a model locomotive. So I dusted off the box and got to work setting up the track on my living room floor. After setting up the track and running a train around it without these printed novelties, I wanted to test the interoperability of the couplers modeled into these 3D printed trucks. Most pieces of modern O-scale equipment have operating couplers that can be opened manually with a lever on the coupler itself or by a magnet in the track. This design also allows the couplers to automatically close when you bump 2 of them together, much like trains in real life. My printed trucks have what could be considered dummy couplers built into them. These are couplers that are permanently in the closed position. This makes them simpler to model and print, but it means that coupling 2 of these printed cars together requires them to be lifted into position. However, they should be capable of coupling to another car with an open automatic coupler. After a successful coupling test, these cars are ready for their maiden voyage around the living room. What can I say? They roll pretty much just like any other rail car that I have. The only downside that I notice is that the boxcar is noticeably louder than the other rolling stock. I think the square axles and the rough plastic contribute to creating vibrations, and the body of the rail car kind of acts like a speaker. Not sure how well the difference in sound will come across on camera, but in real life it kind of sounds like there's a white noise machine playing inside the boxcar. It's not too loud, but it's definitely noticeable compared to the rest of the cars in the train. They seem to be able to handle a decent amount of weight. I put my camera on the flat car and it handled it just fine. Though I will say the noise gets louder with more weight on the axles. Speaking of weight, despite being made entirely of plastic, the DIY boxcar weighs 193 grams while the Lionel boxcar weighs 219 grams. So it's only a 26-gram difference between my version and the Lionel version. Mind you, the Lionel version has metal wheels and axles, but the rest is pretty much entirely plastic. I let the train run for a while, and just as I was about to finish filming, one of the axles fell out of the boxcar. I'm not really sure what happened. Maybe I didn't have it fully inserted to begin with. Maybe something got caught in a way that it ripped out. In any case, I popped the axle back in place and let the train continue running, and I didn't have any further issues with it. Overall, I think it's a fun project. Wouldn't really consider it practical. You're probably better off just going to a model train show and picking up some older rolling stock. There's a lot of print time involved with making one of these boxcars. All the parts for this build are printed at 0.1 millimeter layer heights, and the body of the boxcar took over 2 days to print. It's also fairly wasteful because of the amount of support material. You could print it upside down, but I believe the support will make the top of the roof look pretty rough if you do that. The entire car uses about $7 worth of plastic, so the main advantage is that they're cheap to make compared to O-scale rolling stock, which can get very pricey. They are, however, not very detailed and obviously have no lettering on them. I do think it'd be interesting to try to make one of these using a large resin printer just to see how detailed and how clean you could get one to get right off the printer. I also think it'd be fun to try to model operating couplers into these trucks. Anyway, I just wanted to share this little printing project. Hope you enjoyed it. I'll see you next one, guys. Bye.